Welcome to this FarmBeats for Students video series exploring precision agriculture in the classroom. Hi, I'm Sherry Bordelson, Education Program Manager at Microsoft. I appreciate you taking the time to join me today. In this video series, we will introduce you to the FarmBeats for Students hardware, curriculum, and software and demonstrate how it can be used in the classroom setting. This video will cover section 1 of the curriculum, gathering data through sensors, and with a specific focus on activity 1.3. Let's launch into the 4th video in the series. The main goal of this video series is to familiarize you with the technology used in FarmBeats for Students so that you're equipped to facilitate student activities with digital sensors, data, machine learning, and AI in the context of agriculture and STEM. This video series does not go into depth of all the learning experiences in each activity, as you'll be able to access all that information in the teacher's guide. If you have not watched video 3 and become oriented to activity 1.2, you want to exit this video and head over to video 3 in the FarmBeats playlist. In this video, you're going to learn how to get started with activity 1.3 and use MakeCode to program the microbit and to send a notification when your plant is thirsty. And this activity builds on activity 1.2 as students use the microbit to collect and analyze data for soil moisture, light levels, and air temperature. You will also get a preview of the content included in video 5. First, let's give you the link you need for the FarmBeats for Students website, www.aka.ms/FBFS. On the website, you will find links to download the free curriculum, a link to purchase the affordable hardware kit, and other program information and resources. As mentioned in the last video, FarmBeats for Students uses a microbit-based hardware kit comprising of nails, alligator clips, a soil moisture sensor, a microbit, a battery pack, and a USB cable. MakeCode is the default code editor for the microbit and is used in the FarmBeats for Students program to create programs and download them right onto the microbit. If you watched video 3, you're familiar with this information. FarmBeats for Students microbit-based hardware or microbit-based sensors activities can be run on any device with a web browser, which makes it really easy for everyone. Unit 1, which is what we're learning about now, this is sensors unit, is now appropriate for grades 6 and up, and includes activity scaffolds, differentiation, and extensions, all which can be found in the teacher's guide. This section of the curriculum has 3 activities, so activity 1.1, 1.2, 1.3, and all of those together would take about 5 to 7 instructional days to complete. This can vary, of course, based on age, the course that you're integrating the content into, and the project extensions that you want students to complete. To get oriented to the activities and outcomes for activity 1.3, please pause the video now and read this overview to yourself. Look at the picture to the right. This is the plant monitoring system that students build in activity 1.2. Activity 1.3 builds on top of activity 1.2. Students again program the microbit using MakeCode. However, this time students set up parameters to have the microbit act as an agent to notify them when their plant needs watering. Students download their data and create a data visualization in Excel or another spreadsheet software. This is an example of a flow chart that shows how the temperature, light, and soil moisture data readings must be within specific parameters for the agent to turn on the relay. In this activity, students work collaboratively to construct a flow chart demonstrating how their FarmBeats system can make decisions to irrigate based on sensor readings. You may want to pause the video here to analyze this flowchart. It is important to have students work through this visual logic model so they can set up parameters in their Make Code program. See the teacher's guide for specific activity pointers and a series of how to do this with your students. Students will set up the microbit to act as an agent to observe the environment with sensors, to notify them when their plant needs water. The code is the same as Activity 1.2, but with one extra set of blocks that allow for parameters to be established. Here you will see the new blocks of code in the Make Code program for Activity 1.3. Students will change the zeros to the value of the parameters they want to establish for when their plant needs watering. There are many extensions and possibilities for Section 1 of the curriculum. Remix the Make Code program students used in Activity 1.3 and create a customized notification system. Be creative. Here's some ideas. Students could program the LED display with icons, create sound alerts with customized tunes and melodies, send Bluetooth messages to a device, combine different alerts for a multi-sensory experience, create customizable moisture thresholds through button presses, send radio messages between the microbits, or use a servo motor to create a moving visual notification. In this example, students can make a mini water pump. For example, in this project, students will be constructing a mini water pump using the microbit and Make Code. This project not only enhances their STEM skills, but also encourages creativity as they explore technology and coding to create real-world solution for watering plants automatically. There are other components in this Activity 1.3 around monitoring the soil and the environment. Over 4 days, students will monitor their plant's health and record their observations, adding water if the notification goes off. After 4 days of observing the plant's health, students will connect the microbit to a computer and review their data using the microbit data logger. They will compare notes regarding plant health to the data recorded by the microbit. As a reminder, here's the link you need for the FarmBeats for Students website, www.aka.ms/FBFS. Once you're on the website, you'll find links to download the free curriculum, a link to purchase the affordable hardware kit, and other program information and resources. I hope you'll join us for the next video in this series, Webinar 5, that will cover how to take real-time data that has been collected and create a data visualization. This analysis will allow students to gain greater insights based on their data and make further growing decisions. Thank you for completing this video, and we hope to see you on the other side.